Review of radians, arc length, and area of a sector of a circle. So first, radians. Theta radians is the ratio of arc length over the radius. Arc length over the radius, and must have the same unit. Okay, and we know that 2 pi radians is the whole revolution, 360 degree, and if you divide this by half, pi radians is 180 degree. Now, to convert from degrees to radians, or vice versa, we use proportions. For example, convert the angle to radians. The angle we have minus 300 degrees. We use proportions of the known fact. We know that pi is 180 degree. So on this side is gonna be radians, and on this side is gonna be degrees. So now I have minus 300 degrees, and I don't know what it is. That's called proportion. So now I can divide, put the division equal sign, and we can cross multiply. So we have x times 180, which is 180x, is equal to minus 300 pi. Divide by 180 to isolate for x. So now we divide 180x, divide by 180, minus 300 pi, divide by 180. So this cancel out, and this can be reduced. Divide by 10, we will have minus 30 pi over 18. And this can be reduced even more. Divide by 6. We can divide by 6. We can divide by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. And then we have pi. So it's minus 5/3 pi. So minus 300 degree is equal to minus 5/3 pi. Similar way we convert, we use the same proportion using the 180 and pi if we want to convert from radians to degrees. So convert and to degrees 11 pi over 6 radians. We want to know how many degrees it is. So we use proportions. We know that pi is 180 degree. On that side is radians, on that side is degree. So now I have 11 pi over 6. I don't know what it is. We can put the division, and that's my proportion. We can cross multiply. Pi times x is pi x is equal to, this is not minus, this is the equal sign, right, between them. 11 pi over 6 times 180. So we have 11 pi over 6 times 180. You can go with degree and cancel the radians later on, or we can just go with numbers. So 180 is like over 1. We can divide them. So 6 and 180 can be reduced to 30. So now what we have pi x is equal to 11 pi times 30, which is 330 pi. Now we can divide by pi. We divide by pi. So this cancel out. So we have that x is equal to, the pi cancel out, x is equal to 330 degrees. So 11 pi over 6 radians is 330 degrees. Now we have arc length. Now we have arc length and area of a sector of a circle. Arc length is S is equal to R times theta. Theta must be in radians. S stands for arc length and R stands for radius of the circle. Area of a sector is 1/2 times r squared times theta, and theta must be in radians as well. So now we have example 2. Find the arc length and the area of a sector of a circle with radius 3 centimeters, subtended by the central angle of 100 degrees. So to find the arc length and the area of the sector, both theta must be in radians. So first we need to change 100 degrees to radians. So first change 100 degrees to radians. So we are using that pi is 180 degrees. Now I have 100 degrees, I don't know what it is. So this is my proportion. We can cross multiply. X times 180 is 180x is equal to 100 pi. Divide by 180. This cancel out. So x is equal to, we can reduce this one by 10. If we divide by 10, we get 10 over 18 pi. And this can be reduced even more by 2. It's 5 over 9 pi. So my theta, that was my theta, is 5 over 9 pi. We're going to find the arc length and the area of the sector to the nearest, to the 2 decimal places. To 2 decimal places. So now to find the arc length. We are using formula S is equal to R times theta. My radius is 3 centimeters, which is 3 times my theta is 5 over 9 pi. Now we can either reduce this or just punch on calculator everything. We can reduce 3 and 9 reduces to 3. And then we wanna to the 2 decimal places, so we're gonna divide anyway. So we have 5 divided by 3 times pi. So it's 5.23. So 5.23, 235 and so on. So my S is approximately to 2 decimal places is 5.24 because the digit after 3 is greater than, it's 5 or more, we round it up, centimeter. So that's my arc length. Now the area of the sector of the circle has equation 1/2 r squared times theta. So this is 1/2 times r is 3 squared times my theta is 5/9 pi. We can punch everything on calculator, or we can recognize that this is 9, 3 square is 9, and this will be reduced. This cancel out, 9 and 9 cancel out. So we have 5 over 2 times pi, which is approximately 7 point. So the area is approximately 7.85 centimeter squares. Or punch this one straightforward on the calculator.